Okay, let's get started. Am I too loud? Are you okay? Can you hear me? Okay, good morning, everyone. So today is our formal journey of intermediate macro. We review 3 key concepts on Tuesday. These are the stuff that you have learned in your first year macro. And today, we're going to begin with the first topic, that is the short run of our macroeconomy. So in the short run, economists view that aggregate demand is more important in determining aggregate economic outcome. Here we developed the, can you hear me clearly? Okay, feel there's noise. We developed the so-called ISLM model. What we'll do today is that we'll provide you with the first building block of the ISLM model. We'll derive the IS curve. We'll discuss output, investment, saving. This is from chapter 3 of the textbook and a bit of chapter 5, the first few pages of chapter 5. In particular, there are 4 topics that we'll cover. We first review the GDP components. That is from the demand side. There are 4 components of GDP. We'll review that. And then we'll provide you with the equilibrium condition in goods market. That is when goods market is in equilibrium, what we observe. And then third, we show you that there's another way to look at equilibrium condition in the goods market, the investment saving approach. And lastly, we'll formally derive the IS curve. This is the plan for today's lecture. Okay, so on Tuesday, we argued that there are 3 ways to calculate GDP, right? Remember that from production side or income side. And economists look at GDP, and there's another way to think about GDP. That is from the perspective who purchases these goods and services. We can decompose GDP into the following 4 components. That is consumption. That refers to the goods and services purchased by consumers like you and me, right? You buy a computer, you buy a bottle of water. These will be part of the consumption in GDP. And the second component is called investment. Here, notice investment refers to the investment of physical capital. That is, if a firm buys a new plant or a new equipment, this would be part of the investment in GDP. It doesn't refer to financial investment, because when we talk about investment in daily life, you think about your portfolio in the bank. Investment here in GDP is not financial investment. It has nothing to do with financial investment. Rather, it refers to investment, the purchases of capital goods. It includes, of course, non-residential investment like plants, equipments, computers, chairs, desks, all this stuff. It also includes residential investment, only the purchase or the building of new houses. That's the investment, second component. The third component is if, say, government builds a new hospital or builds a new freeway, all this type of expenditure, it belongs to government purchase or government spending. Here, it refers to the part of goods and services purchased by the government. So that's the third component of GDP. Then there's a last component. Remember, GDP refers to the goods and services produced within a country during a given period of time, right? Think about your consumption. When you buy an iPhone or your Mac, so is it part of the good produced within Australia? No, right? But it's your consumption, so it's included in consumption. Somehow we need to adjust this. That's why we subtract import. Here, this IM refers to import. We subtract import when we calculate GDP. And also, what if foreigners need Australian goods? Like Australian, these boots, UGG boots, they are really popular, right? If foreigners purchase these Australian goods, of course, this is part of the production within Australia, but it's not accounted yet in consumption investment or government spending, right? That's why we need to add exports when we think about Australian GDP. So putting all together, there are 4 components of GDP from the perspective who demand or who purchases our goods and services, consumption, goods and services purchased by consumers, investment, capital goods purchased by firms, and government spending. This is the goods and services purchased by the government. And lastly, this net export, export minus import. Oh, one more comment on government spending is that this refers to the government purchase of goods and services. If you learn anything about the government spending, you know government has other expenditure. For example, I have a daughter in a daycare. I receive the childcare rebate from the government every month. So this part of the expenditure is not part of the government spending here because the government transfer payment to me does not represent any new production of goods and services, right? So here it refers to only the government expenditure on goods and services. It doesn't include any transfer payment. So let's take a look at an example of these 4 components of GDP. You see here, we have the Australian GDP in 2011, and we have the raw number, that's $1,335 billion, and we also look at the fraction of each component. Consumption, investment, government spending, and net exports. These are the 4 most important components in GDP, and it turns out in Australia, consumption is still the largest fraction in GDP, right? And there is a minor thing that we won't cover in our class. We'll ignore that. That's the inventory investment. In Australia, this accounts for about 0.3% of total GDP. And what is that? This is basically if a firm produces a certain number of output and they sell some of it, there are some leftovers, right? This part is accounted as inventory investment. That is the firm's production minus sales. This is a tiny fraction in aggregate GDP. That's why we don't discuss this in our class. We'll ignore this tiny part. That's here we view GDP consisting of 4 components from the perspective who demand the goods and services, consumption, investment, government spending or government purchase, and net export. Now, we are ready to develop our theory. What we want to do next is that we want to look at the short-term macroeconomy, that is, aggregate output is more or less determined by aggregate demand. Well, does it make sense? This is to say that in the very short run, demand is more important in driving aggregate economic outcome. That is, we kind of keep the supply side silent or passive. No matter how much is demanded in the economy, the firms or the production side of the economy will be able to supply it. It's kind of a plausible assumption in the very short run because you can think that firms can kind of operate over capacity in the very short run in maybe in a few months or in a few years, but not over long run. That's why we think that in the short run, assumption 1 here behind this model, assumption 1 is that we keep supply side passive or silent for now. We've assumed that the supply side can always satisfy demand. And here, demand is the key factor that determines aggregate output. We don't look at the supply side yet. But after the first 4 weeks, we'll bring the supply side back into our picture. So don't worry yet. This is only the short run. We only look at the demand side. We'll talk about supply side later. The second assumption is, if you think of aggregate demand, I don't know if any of you has already thought about it. Like there are thousands of goods in the economy, right? And we talk about aggregate demand. Is it demand for apples or bananas or computers or what? And simply we can't account for all these different types of demand. That's why we also make a simplifying assumption here by saying that let's consider there is this representative kind of good in the economy. We'll simplify the economy into this one good economy and look at the supply and demand for this particular representative good. That's why we have one single demand equation for this good in the economy, and that's the second assumption we're using behind deriving this IS curve. Now, we're ready to go through some math here. Having reviewed the 4 components of GDP, we know that we can define aggregate demand in the following way. Let's use this capital letter Z to denote aggregate demand. Notice that this is not an equation, right? Notice the subtle difference. I have like this triple line here. What does it mean? This means an identity. Identity means this is true by definition. We define aggregate demand Z as the sum of consumption, capital letter C, investment, capital I, capital letter I, government spending, capital letter G, and net export. That's export X minus imports IM, this notation. This is how we define aggregate demand. This is always true, a definition. And then, again, as I mentioned on Tuesday's lecture, that we want to start with a simple scenario where we don't look at the open economy yet. We assume that we have a closed economy where export equals imports equals 0. If you're interested in exchange rate and all this trade stuff, wait till topic 5. We'll bring everything back. But for now, we assume a closed economy so that aggregate demand is simply the sum of consumption, investment, and government spending. We ignore the export-import for now. Okay, now let's look at each component in aggregate demand. Because we want to understand what determines aggregate demand in the short term, we argue that aggregate demand is important in determining aggregate output. And then what determines aggregate demand? Consumption, investment, and government spending, right? Let's look at each component one by one. First, consumption. If you think about what determines your consumption choice, what would be the main factor? Anything? Money, right? Money, income. That's exactly what we're having here. Economists find that income is the primary factor that determines households' consumption decision. That's why there is a behavioral assumption here, assuming that consumption, this one, is a simple function of aggregate income. And be very careful. Say, if I earn $100, can I spend all of my $100? Maybe not, because I need to pay taxes to government, right? This is how government raises revenue. That's why we introduced the notion of aggregate disposable income. This is the part of income that you're left after paying the tax. But that's given by, in aggregate terms, that's given by the difference between income Y and tax payment. So we introduce a new notation here, taxes. This is how the government raises revenue, right? The government has spending G, so how can the government support the spending? By taxes. And disposable income is defined as the difference between income and taxes, and we assume that consumption is a function of disposable income. Not too bad, right? In particular, you can imagine that the more disposable income you have, probably you want to consume more, right? That's a plausible assumption. I'll give you a very simple example of a linear product consumption function. It says that consumption is a function of disposable income. In particular, it depends on disposable income in the following way. Consumption equals a parameter here, C0. We give it a name. It's called autonomous consumption. And the second part is C1 times disposable income. We call C1 the marginal propensity to consume. That is, if you have $1 extra, how much more consumption you will have. That's the meaning of C1. That's called the marginal propensity to consume. And C0 is autonomous consumption. It means that even if your disposable income is 0, you still need to eat, right? Even if you don't earn anything, you're still hungry, you need to eat. You have some basic consumption. This C0 is called the autonomous consumption. It reflects kind of the basic consumption you must have, even if your income is 0. Generally, we assume that C0 and C1 are greater than 0. And the other thing about this marginal propensity to consume is that it's less than 1. What does it mean? It means that if you have $1 more, you spend part of it. You won't spend $1.50. So that's kind of reasonable assumption, right? If you have some money, some extra dollar, you want to spend part of it, not all of it. That's why C1 is generally less than 1. This is a plot of the consumption function in the space of here, disposable income and consumption. You see this is linear, right? With the intercept, this autonomous consumption, C0, right? That is when disposable income is 0, intercept is C0, and slope is given by the C1. Marginal propensity to consume. It's less than 1, between 0 and 1. Now, what about the other components? Well, for now, we keep everything very simple, have a simple start. We assume that investment, government spending, and taxes, they are all exogenous. What does it mean by exogenous? In economics, we often talk about exogenous versus endogenous. Exogenous means that we take these variables as given. So these variables don't depend on anything else. We take this as given. Whereas endogenous means that this variable is determined within this particular model, like consumption in our case is endogenous. But for now, we assume the rest of this investment, government spending, and taxes, these are exogenous. As I said, government spending and taxes, they're described by the fiscal policy. We'll talk a little bit more about that in probably 10 minutes. Now, let's put everything together. We're ready to derive the first important result with the simple setup, aggregate demand. And where short run, aggregate demand determines output. In the short run, as we emphasize again and again, aggregate demand is important in determining output. That's why the equilibrium condition. Notice that there's a difference between equilibrium condition and not in equilibrium. Aggregate demand is defined by the sum of consumption, investment, and government spending. This is definition. And only in equilibrium, when the goods market is in equilibrium, we have the following. Aggregate demand equals aggregate output. That is the supply of output, this is Y, the production, just meet aggregate demand. This is an equilibrium condition. We introduce a definition that is aggregate demand is the sum of consumption, investment, and government spending. That's a definition. But this one, notice the equal sign. This is an equilibrium condition. This is when goods market is in the equilibrium situation, we have that. Aggregate demand determines aggregate output. And remember that we calculate GDP either from the production side or income side. So this Y is also aggregate income. And what we are having now is that aggregate demand itself, by definition, is given by consumption plus investment plus government spending, which equals aggregate output in equilibrium, right? So this equation, C equals this whole thing, is the definition of aggregate demand. When the goods market is in equilibrium, we have the second, the one that I add there. That is, all this aggregate demand should equal aggregate output. That's the equilibrium in goods market. And now, notice that what happened is aggregate demand itself depends on aggregate income or aggregate output. We use these two terms interchangeably. And it seems we are left with something not too bad. See, we have now taking taxes, investment, and government spending as exogenous. We are now left with this one equation, the one unknown, right? The only unknown is aggregate output. That is, in the short run, when aggregate demand equals output, we can find the equilibrium output. What is it? You can solve for this one equation, one unknown here. Yeah, here. So solving that one equation, one unknown, you can find the equilibrium output in this economy is given by that formula, 1 over 1 minus C1 times this whole thing. Graphically, we can think of the following result as this in this diagram. what happened is we have two conditions, right? One is the definition of aggregate demand. So that is C equals C plus I plus G, which is, I'm repeating what we had in the previous slide. So this is one condition, that's the definition of aggregate demand. We can simply plot this on the diagram where we take income as the horizontal axis and we put demand on the vertical axis. This is given by this gray upward sloping line, right? If you plot aggregate demand as a function of income, we have an upward sloping line. In particular, the slope is given by C1 and the intercept, here it is minus. So that's the whole intercept plus C1y, right? You basically collect everything without y, that will be the intercept, and the rest, C1 times y, give us the slope. So here, we have the slope of this aggregate demand line, C1, and this vertical intercept, the name for it is called autonomous spending. That is, even when income is zero, you still have some demand in the economy, this autonomous spending. Now, what's the second condition that gives us the goods market equilibrium? That's the condition where we say, if the goods market is in equilibrium, aggregate demand equals output, right? So the second condition is this. Right? Simply as that. The two important things here, one is the definition of aggregate demand, the second is the equilibrium condition. How to plot this one? In the space of demand and income, where income is horizontal axis and demand is vertical axis, this is a 45-degree line, right? You're good at graphics? Like this is 45-degree line. That's why when you put the equilibrium condition together with the definition of aggregate demand, what happened is this 45-degree line is this orange one. You find that the intersection gives us the equilibrium in goods market. That's the kind of equilibrium output in this economy. That's the one we solve in the next slide. So we define aggregate demand as a function of aggregate income. And we know that in the short run, the equilibrium in goods market is given by when aggregate demand equals aggregate output or aggregate income. In this case, we can solve for that unique aggregate income that satisfies this goods market equilibrium condition. This is what the intersection A gives us, right? This is the only level of aggregate output or aggregate income that satisfies goods market equilibrium condition, right? Now we look at each component in the solution. We first look at this first part. We call this a formal name the multiplier. It turns out this multiplier is really important in determining short-run macroeconomic outcome. The second part, as we introduced, is called autonomous spending. What does the multiplier tell us is that if the autonomous spending increased by 1 unit, what happened to aggregate output or aggregate income? And it turns out, suppose let's take one example, what if G, government spending, increased by 1 unit? If government spending increased by 1 unit, without looking at the next slide, let's think about it together. If government spending increased by 1 unit, what do you think of aggregate output? That will increase for sure, right? But will our aggregate output increase by 1 unit? No, that's right. That's very good thinking. It will actually increase by more than 1 unit. Mathematically, from that solution, you can probably find that if G increased by 1 unit, aggregate output will increase by 1 over 1 minus C1 unit, right? That's the multiplier. But intuitively, what's going on? If government spending increased by 1 unit. That directly contributes to a 1 unit increase in Y, aggregate output, right? But remember, there's something else in the aggregate demand that depends on Y. What is it? Consumption, exactly. So consumption, in response to an increase in Y, disposable income will then increase, and then consumption will increase, right? By what? By C1 in the first round. And then if consumption increased by C1, that contributes to C1 units increase in aggregate output, right? And if aggregate output increased by C1, then consumption will increase again, aggregate output will increase again, and this will go on for many, many rounds. Technically, this is exactly what's going on here. Let me repeat this following process. Hope you are with me. If government spending increased by 1 unit, that's 1 unit increase in autonomous spending, what's happening to the aggregate demand is that this ZZ line will shift up. Why? Because the slope of the ZZ line depends on C1, marginal propensity to consume, right? The increase in government spending does not affect the slope. And G actually enter into the intercept, right? Part of the autonomous spending. So 1 unit increase in government spending shift up the ZZ line, and that's the first round increase in aggregate output. The direct impact of the increase in government spending will increase aggregate output by 1. But that's not the end of it. Just as we discussed, the 1 increase in aggregate output will mean that on the horizontal axis, this aggregate output increased by 1 unit. Because consumption depends on disposable income, which depends on aggregate income, the increase in aggregate income by 1 means consumption will increase by C1, right? That's the second round. So this distance CD gives us this round of increase in consumption. Why C1 is here is because the slope of this ZZ line is C1. And that's not the end of it, because when consumption increases by C1, aggregate income will increase by C1, and then consumption will increase again. And this will go on for many, many rounds. When does it stop? Basically, as we discussed, the first round, direct effect, increase in output by 1. The second round, indirect effect from the marginal propensity to consume, consumption increase by C1. As you can imagine, the next round will be increase by C1 times C1. And then this will go on for many, many rounds. Up to the nth rounds, we'll have the overall impact on aggregate output given by the sum of this 1 plus C1, C1 squared, C1 all the way to the power n minus 1, right? So we have to sum all this up together to find the ultimate impact of the increase in autonomous spending on output. Well, that doesn't look very pretty. There are many items here, the bottom expression. But if you have some math background, you know, this is actually not too bad, because the limit of this geometric sum here can be given by a very nice formula. If C1 is between 0 and 1, we can show that the sum of all this is given by 1 over 1 minus C1. That's how we get the multiplier. That is, 1 unit increase in autonomous spending will trigger many rounds of change, and the ultimate impact of output is given by this multiplier. And let's take a look at an example. Say if C1 is 0.2, marginal propensity is very small. So you only spend like a fifth of your extra dollar. And in this case, the multiplier is 1.25. That is, 1 unit increase in government spending will increase output by 1.25. Whereas if marginal propensity is higher, 0.5, to spend half of your dollar if you have 4 extra dollar, that multiplier is 2. So the impact on output is bigger here. And furthermore, if marginal propensity to spend is really high, like 0.8, you spend almost everything when you get that extra dollar, it turns out that multiplier is really big. It turns out that this marginal propensity to consume has a direct effect on the multiplier, right? The bigger the marginal propensity to consume, the bigger the multiplier. This makes sense, right? It means that when you have any increase in income, your consumption responds more, and in this case, there will be bigger impact on output, right? So the bigger the marginal propensity to consume, the bigger this multiplier is. So what is your marginal propensity to consume? So if you have, say, $100 more, how much would you spend? Nothing, or 110? So we don't allow that here. In general, economists estimate the marginal propensity to consume in Australia for average Australian household is about 1/2. So are you a typical Australian household? Spend half of that extra dollar. That's the marginal propensity to consume in Australia. And this multiplier is the key factor that determines the short-run macroeconomic fluctuation. So that's basically the first equilibrium condition we introduce, and then we can solve for the equilibrium level of output that is consistent with equilibrium in goods market. This is where aggregate demand equals output. We show next, there's another way to represent this equilibrium condition. Remember, the equilibrium condition so far we use is aggregate demand equals output, right? Because we argue in the short run, production or output is determined by demand. That's the equilibrium condition. Now, there's another way to look at this. What we want to define next, notice we have this triple line again. This is how we define private saving. The aggregate private saving is defined as the difference between disposable income and consumption. That means if you have a certain amount of disposable income, the part that you don't consume will be classified saving here, private saving. And then if you follow the definition, of disposable income, you find that saving is given by the second equation here. And next, remember the equilibrium condition we have used so far is this y equals g, which is c plus I plus g, right? And now what we will do is we want to show you this equilibrium condition leads to another condition. If we substitute this condition by substituting y into that, what we find is that saving equals c plus I plus g, right? That's y minus t minus c, right? We want to rearrange it a bit, cancel the c. We are left with the following. I put I on one side and the rest on the other side. Right? So this is the second condition that is actually equivalent to that goods market equilibrium condition. That's why we argue that these are like two sides of one coin. It says that the other way to put the goods market equilibrium condition is where investment equals saving. In particular, saving is the sum of private saving, this S, and public saving, T minus G. Why T minus G is called public saving? Because both taxes and government spending are described by fiscal policy. When government collects more taxes than it spends, like when T is greater than G, this is where the government will have a saving, right? It has more revenue than expenditure. This is where we have a budget surplus, government budget surplus. On the other hand, when taxes are less than government spending, this is when the government runs a government budget deficit. In this case, we have negative public saving, right? This T minus G gives us the public saving. And we argue that you can view the goods market equilibrium condition in another way. You can either view it as when aggregate demand equals output, that's one way, or this is where investment equals saving, where saving is the sum of public saving and private saving. We just show you that from this condition, one type of equilibrium condition, we can derive the other. You can actually work out by yourself. If you start from this one, you can actually find that this leads to that, the other condition. So these two conditions, one imply another. So these are like two sides of one coin. And that's why the IS curve is called the IS curve. This follows this investment saving approach. The IS curve basically describes equilibrium in goods market. And since equilibrium in goods market can be represented by the second condition, investment equals saving, it has the name IS curve. It's from investment and saving. So before we endogenize investment, let's discuss one particular application of our simple theory so far. So we have found that output in equilibrium, in this case, is determined by the multiplier times by the autonomous spending, right? And it seems to suggest that if the government really want to stimulate the economy, say, increase output, one way is just to manipulate government spending or taxes, right? Because you can just fine-tune government spending to reach a certain level of output. Well, is it a good policy recommendation? Well, our very simple model seems to suggest that, but we want to warn you with a few caveats here. There are some danger here. We can't really use this as a very useful policy recommendation yet. Yes, this is the implication from our simple theory, but in practice, if you suggest the government to adjust government spending to reach a certain level of output, there are some important information that you should know. First, if you want to adjust government spending to determine output level, the value of the multiplier is important, right? But do we have a reliable estimate of the multiplier? This is still an open question, right? Without knowing the exact magnitude of the multiplier, you won't know what's the ultimate impact of the increase in government spending on output, right? And second, in practice, the horizon of the policy is very important. If the government announces a temporary tax cut versus a permanent tax cut, think about it, you would react differently. Like if the government says that the tax will be lower just for one period, this won't affect you much. Yes, it's good, you have more disposable income, but this doesn't last forever. However, if the tax cut is forever, this is good for us, right? It means we have more disposable income every period from now on. So that will trigger you to change your consumption behavior, most likely. So that's why when you think about fiscal policy in practice, this time horizon of the policy is very important. And third, we haven't talked about the supply side yet. If you use government spending to stimulate the economy, there's a danger that is if the government has a lot of spending, that increases demand, and that will increase the general price level in the economy over a longer horizon. We're talking about a very short run where we kind of fix the price and think about supply as passive. But in a longer horizon, if you keep doing this, what happens is ultimately the economy will hit capacity constraint. There will be a lot of demand chasing a limited number of goods. Price will increase. The economy might be overheated. So that's not something that we generally want. And lastly, of course, if the government increases government spending, this will incur more government debt, and how to repay this debt in the future will be an issue, right? And moreover, we'll show you probably in the lecture next week that the increase in government spending, this is kind of public investment, will generally crowd out private investment. So these are the few issues that you want to know before using our very simple model to make any policy recommendation. So next, what we want to do is, so far we have had a very simple scenario where apart from consumption, everything else is exogenous. Let's take one step further. What if we make investment endogenous? That is, instead of assuming that investment is given, we think that investment also depends on something in the economy. What does investment depend on? Here, we assume another kind of behavioral assumption, that is aggregate investment demand depends on two factors. output or aggregate income, and interest rate. Suppose you are firm owners and think about whether you should invest more. What is important for you? If you see the economy is booming, like output is high and everybody is happy, more production, is this the time that you want to make more investment? Probably yes, right? Because you know that the economy is really doing well, let's make more investment, and probably I can sell my products, right, by investing. So that's why generally we assume that investment depends in a positive way on output or aggregate income. When the economy is producing more, this is a good time for you to make investment because it's more likely you can sell what you produce and good opportunity. So B1, a parameter in the investment function, is positive. Second, interest rate. Well, remember I said that investment here doesn't refer to your portfolio investment in your bank account. Rather, this is physical investment. In general, to finance physical investment, we think that firm owners need to raise funds, right? So interest rate represents the opportunity cost of raising funds, right? The cost of funds. When the interest rate is really high, it means that it's really expensive for you to raise any funds. And in this case, would you like to make a lot of investment? Probably no. That's why generally we assume that B2, another parameter, is bigger than 0, but minus B2 is negative. That is, investment depends negatively on interest rate. Interest rate represents cost of funds. When the interest rate is high, it's very costly for you to raise funds to make investment. You'd better reduce your investment. But when interest rate is low, this is really cheap for you to make investment, so you increase your investment demand. Generally, investment depends positively on income and negatively on interest rate. And this B0 is another parameter, sort of like this autonomous investment, that type of thing. So kind of intercept parameter. So this is the investment demand. It depends on income and interest rate. Why do we want to do that? Because in this case, if we put everything together, again, this gives us the goods market equilibrium, right? Output equals demand here, equals C plus I plus G. And now what we do is we substitute C, the consumption function, in. We also substitute I, the investment function, in. What we are left with is this, the first one. Y equals first consumption plus second investment plus government spending. We still keep government spending as exogenous here. Again, we are left with one equation, and I'm a little reluctant to say one unknown yet because now we have interest rate, right? What we can do though is to express output Y as a function of interest rate, right? Before, when we have an exogenous investment, we can find the equilibrium level of output simply as a function of multiplier and autonomous spending. But now, by introducing the investment demand equation, what we're having is we can solve for the equilibrium level of Y. What you do is you put everything with Y on the left-hand side, collect the terms, and solve for equilibrium of Y as a function of the new multiplier here and the new autonomous spending, which depends on interest rate. So what does this equation tell us is that when the goods market is in equilibrium, when demand equals output, there's a combination of output Y and interest rate that give us this equilibrium, right? So basically, this is the IS curve. The IS curve gives us the combination of output and interest rates that are consistent with equilibrium in goods market. So these are all the combination of output and interest rates that give rise to equilibrium in goods market. And we can actually plot this condition in the space of interest rate and output. It would be downward sloping, something like that. We'll show you formally this in next week's lecture. But to give you a preview, if you have output here and interest here, right here, you have this IS curve, downward sloping. So IS curve describes equilibrium condition in goods market, and all the points are the combination of output and interest rates that are consistent with goods market equilibrium. This is the first building block of the ISLM model. It describes equilibrium in goods market. In next week, we'll begin with developing the LM curve and then putting these two building blocks together to apply this model, analyze the short-run macroeconomy. And what we often do in the second lecture is I want to show you one example and show you how we apply the knowledge we learned in this week to do the exercise. This would be something that you can see in tutorials or in the exam. This is the type of exercise we can ask you after learning this week's lecture. So this question here is, suppose we give you a particular consumption function, right? Still the linear one, autonomous consumption 100, marginal propensity to consume a half, disposable income is this YD. We'll give you exogenous investment, that's 50, government purchase G 20, and taxes 20. We ask you to solve for equilibrium output and equilibrium consumption. How to do this type of question? In general, recall what you have learned so far. Two things you must know from today's lecture. One is the definition of aggregate demand. That is, aggregate demand is the sum of consumption, investment, and government spending. Second thing you must remember is the equilibrium condition in goods market is given by when aggregate demand equals output. In the short run, output is determined by aggregate demand. So let's put these two things together. We'll be almost done. So here we combine these two things. Output equals demand equals the C plus I plus G. And we just put the information that we have so far in, investment 50, government spending 20, and then we also construct this disposable income as the difference between output and taxes, and put taxes in as 20. We have this equation 2, the consumption function, right? Next, let's put everything in. We have Y equals here consumption plus the 70. This is basically I plus G, right? One equation, one unknown. Do we know what's the equilibrium outcome in this situation, in the short run in this economy? Let's solve for it, right? Put Y on the left-hand side, you have Y minus 0.5 Y equals 100 minus 10 plus 70. That's 160. And then you can find Y would be 320. And what is consumption? Back to the consumption function, by plugging in Y, the value of Y is 320, you have consumption being 250 here. So that's a very simple example showing you what kind of exercise you're expected to do after learning this week's lecture. I'll provide the answer on LMS after today's lecture, so don't worry about copying down all this. I'll post the answer on LMS. That's all for today, and see you next Tuesday. But if you use B, you can derive A. You use just one of the two. You don't need both of them, right? Just use one. Suppose this is condition A and the investment second expression is condition B. We argue that either A or B could give you the equilibrium use, not Oh, yeah, sure.
Bye.
Yes. Oh, I see. I think, yeah, this is more subjective. I think some students may find video more helpful, but overall, I think lectures are still the most important components. So if you feel you understand everything in the lecture, you should be able to do the exercise. I mean, lecture one, lecture two. Yeah. This is for autonomous consumption. The other part, the big thing is for autonomous spending. It doesn't have a formal name, so that's why I say it's sort of like autonomous spending, but it's still directing.
Yeah, is that yours?
Yeah, that's mine. I have two things. One is one has a wire. I probably is it the basic econometrics?
No introduction.
Yes. For second year?
Yeah. The numbers went up from 2 to 400.
Oh, okay.
What about you?
I have 900 something. It used to be 700.
Yeah. So you're doing three streams?
True. That's
Oh,
why
that's
I managed to. We actually swapped the lecture venue so that I can still have two, three. Now I can go up to 900.
So they're both in here?
This is one stream, one here, the other one lecture in Kathleen Fitzpatrick. So these hold around.
Oh, so you're all coding over that.
Yeah. The other stream is all in old art. That's 400. So I have 900 in total, but they can go overflow 10%. They can go up to 990.
Yeah.
For my other subject, manual banking, I have changed classroom twice.
Yeah, no, this is what happened to me. I was over the wall, which is really good because it's like 5 minutes from the office. But it only takes 391.
I know. It actually, on Tuesday, I had a lecture in physics south, and I feel that I'm completely exhausted after that morning lecture. It's really long walk.
Yeah, you have to kind of make sure you get your
Yeah.
I guess we'll be tag teaming. Hello, Friday.
Right. See you soon.